Hey guys, today we're graphing tangents, and this is going to be page 52 in your notes packet. Okay, the first thing you should see on this page is this key points table. All right, and you'll remember we had key points when we came to graphing sines and cosines. We had things like 0, pi over 2, pi, 3 pi over 2, and 2 pi as your angles, and we had the sines and cosines of those values. Okay. Again, now tangents are going to have their own set of key points, all right? And the angles that we're going to choose are going to be starting from negative pi over 2, then negative pi over 4, 0, pi over 4, and pi over 2, okay? So you'll notice they're pretty much mirror images of each other, right? It starts from negative pi over 2 and goes up to pi over 2. Again, we're going to choose these because they're going to give us some very easy tangents to work with, and they capture the full picture of the graph, right? If you look right next to this table, you'll see a picture of what this graph looks like. It's making a bunch of these repeating waves, all right? And we do want to capture all of that information, okay? So we can go to the unit circle, and if we go to the unit circle, we can pull all of the x and y values for these points. Okay, now you'll see I went ahead and filled that table in for you in red, and those values in red again came from my unit circle. All I did was go to that correct angle and find those values, okay? So now, tangent, we're actually trying to graph, is y divided by x, right? So what we're going to do is we're going to take a second and we're going to divide each of these numbers, right? Well, negative 1 dividing by 0 always gives me undefined, okay? Now, you'll notice this one, these numbers are the same except for this negative sign, and I will divide to get negative 1, all right? Once I've got that negative 1, the next one, 0 divided by 1 is 0. Root 2 over 2 divided by root 2 over 2 is going to give me a positive 1 this time. And the last one, again, is going to give me undefined, okay? So these two columns that I'm going to highlight, the graph column and the angle, are going to be my values that I use for tangent, okay? So if I was saying, hey, what are my key points for tangent? You would list them out like this: negative pi over 2, comma, undefined, pi over 4, right? And that's going to be negative 1. We've got 0 and 0. We've got pi over 4, positive this time, 1, and pi over 2, and undefined once again. So these are the key points for tangent. Again, these are just coordinates that go x, y, okay? And we're going to adjust them the same way we had to adjust the points for sine and cosine and make the graphs, right? They were transformed, shifted, stretched, etc. So we're going to do the same thing with our tangents in a second, all right? Before we do that, though, I want to go ahead and go on to the table that you have included there. Okay, now this box is filled with a ton of information, and I just want to take a second to cover some of the key features about the tangent graph. Okay, so if you look at the intercepts of the tangent graph, you have a picture in front of you. You'll notice that these intercepts start happening from 0, then they go to pi, then they go to 2 pi, and then 3 pi, and you can kind of guess that pattern, right? So what are we saying? That every pi, and including negatives actually, so the pattern here is going to be pi n, all right? N is again representing any number of times that I do this, either positive or negative, okay? So those are the intercepts, or my zeros, for the tangent function. All right. Now, domain is kind of interesting. If you study the domain of this, you'll notice, wait, there are breaks in my graph, and those we call asymptotes, right? So the domain is actually dependent on the asymptotes, and the asymptotes actually happen at every pi over 2 sections. So pi over 2, 3 pi over 2, 5 pi over 2, right? And if we wanted to go backwards, we could even say negative pi over 2. Okay, so that pattern is actually x equals pi over 2 plus pi n. Okay, so that is the pattern for the asymptotes. All right, and the domain is literally everything that is not an asymptote. Okay, so what we're going to say for the domain is that x does not equal the numbers that we just came up with, which is pi over 2 plus pi n. Now, this is dependent on the period, guys, okay? So I'm going to make a note off to the side here. And what this note says is that the general form for asymptotes is going to be the first asymptote plus the period times n, okay? So when we transform, our asymptotes are actually going to move around with the graph, right, when we stretch it or shrink it. And we just want to note that, yes, it's going to be the first asymptote that you find, and it'll be plus the period times n, okay? All right, let's keep going through these features. We've also got the range for tangents, and the range is very simple, guys. It goes from negative infinity until positive infinity, okay? Tangent doesn't have any restrictions on the domain, and so that one's very simple, okay? They mention a few key facts here as well. The next line says the midpoint between two intercepts is the x-intercept. What they actually meant to say is the midpoint between two asymptotes, all right, is the x-intercept. So halfway between your asymptotes is that center point. The amplitude is always written as being undefined, and basically this graph always repeats itself. So once you've drawn the first picture, that first form of it, you can keep copying it over to get more sections of the graph. Okay, now let's start trying to make a graph for this. Okay, I took a second and I noted down the key points for tangent off on the right-hand side of the page. So these are the same numbers we came up with on that chart on the front page. And I just want to say, hey, those are going to be the same numbers I'm going to use again when I graph this. Okay, so the first thing is they ask us, can we identify all the transformations that have taken place on this? Okay, so I see y equals tangent x over 2, all right? The tangent, that 3, is going to be a vertical stretch, and it's going to be by 3. So it's 3 times taller or steeper than my original tangent graph. And the next thing I see is this x divided by 2. So the inside of my functions are always backwards. So this is a horizontal, not a shrink, but a stretch. And that is also going to be by 2. Okay, so it's actually a reverse, not by 1/2, but rather by 2. Okay, remember you could write that as 1/2 x. All right, so now that we've identified our transformations, we know that it's a vertical stretch by 3 and a horizontal stretch by 2. We can try to make our graph now. So we'll start with our key values again, theta. I'm just copying these numbers down first. Pi over 2, that one's negative. Then we've got negative pi over 4, 0, pi over 4, and pi over 2. And I'm going to go ahead and start changing my x values first. So first one is the horizontal stretch by 2, right? That's going to affect my x values that was inside my parentheses. So we'll come over here and we're going to say, hey, I need to stretch this graph by 2. Let's do times 2. Remember, it's always the reverse of the math you saw in the function. So it says x divided by 2, but I don't want to divide by 2. I'm going to multiply by 2 instead. So each of these points we're going to multiply by 2. I've got negative pi over 2, 0, pi over 2, and pi as my coordinates now. Now there's no other horizontal transformations, so let's take a second and just mark that this is going to be my x values for this function, all right? Now, once I've locked in my x values, I'm going to go ahead and continue. Let's make the y values, okay? So I've written out the tangents over here. My y values are undefined, -1, 0, 1, and undefined. And let's see what's happening there, okay? We are being stretched by a factor of 3. So we're going to say, hey, we're going to be times 3, all right? So that is my vertical stretch right here by a factor of 3, right? That's that a value in the front. So now we can fill these values in. Guys, any math with undefined is going to stay undefined, all right? Then we've got -3, 0, 3, and still undefined again. And we can go ahead and lock that in now as my y values because there's no more transformations. Now, in case you've forgotten, guys, these are actually going to be my x and y coordinates that I've come up with. We've got -pi and undefined as my first coordinate. So if I were to go find that, how do I graph something that's undefined? All right. For tangents, that means that there is an asymptote at that location. So I'm going to go ahead and mark the asymptote, both of them, on my graph real quick. All right. And let's see how this shape starts coming together now. So if I were graphing this, let's go ahead and go -pi/2, -3. So here's -pi/2 and -3. Right about there, I've got a point. And then I've got a point here at 0, 0. And pi/2, I've got another point at 3. Okay. Now, the rest of this graph, it looks kind of just like a cubic. You curve this one upwards, and it's going to head straight towards this asymptote. This one's going to curve downwards towards that asymptote. And voila, you've got your tangent graph. Okay, so my suggestion, graph these asymptotes first, right? And we can even make a note that these are our asymptotes. Okay. So those are my asymptotes. In between, you're going to have 3 points, and it makes like almost a cubic shape to make your graph, right? So we can note this as cubic shape. All right. So before I go on, let's just take a second to talk about the period for these. The period for sines and cosines was going to be 2π/b. But for tangents and cotangents in the future, you're going to see that your period is instead π/b. Okay? For tangents. All right. So that is a helpful piece of information and something we should keep track of. So in this case, my b value ends up being 1/2, that horizontal transformation. And I've got π/1/2, which leads me to 2π for this specific one, okay? But this is the general formula for tangent periods, okay? The reason we want that is really that's how we're going to come up with that equation for asymptotes and stuff as well, okay? All right, guys, if you're feeling comfortable with graphing tangents, take a second, pause this video, and give it a shot on this one. Try it out, and then check if you get the same answer that I do, okay? Now, one word of warning to the wise, this one is unfactored, okay? So we should start out by just rewriting this as -3 tangent 2x plus π/4, all right? And that's a little crowded there, but what I want to point out to you is that this has a b value that's mixed in, and that is very dangerous if we're not careful, okay? So let's see how far you can get in this before I start filling it in. So pause the video, see if you can come up with the transformations. All right, so if you came up with these transformations, I think you would have found that first, there's a negative in the front. That is a vertical reflection. And then there's the number 3 there. So that is a vertical stretch by 3. And this 2, I'm going to note, that's horizontal. right? This section is all with my x values. That is a horizontal shrink, not a stretch, a shrink by, not 2, we're going to say by 1/2, right? I'm dividing by 2 instead. And finally, this pi over 4 is going to be a phase shift, and it is going to the left pi over 4. Okay, so those are my transformations. Okay, if you're feeling comfortable, again, guys, go ahead and progress forward. Try to make the table and start filling in this graph. All right, so we'll start with the key points for this. And again, I have to start with theta. So negative pi over 2, negative pi over 4, 0, pi over 4, and pi over 2. Standard values, guys. We use the same ones for every single tangent function. All right, and let's go ahead and handle these horizontal transformations. Those are the ones I wrote in red. They affect the x values. And I'm going to start with my horizontal shrink because we multiply before we add or subtract. So I'm going to go ahead and say, hey, let's multiply by 1/2. All right, and that's going to give me negative pi over 4, negative pi over 8, 0, pi over 8, and pi over 4. Now, I have another transformation on the x values, right? That phase shift to the left pi over 4. So going left means I know I need to subtract pi over 4. So I'm going to go ahead and fill in these values now. So I'm going to take the second column of numbers and I'm going to subtract pi over 4. And we should start getting some new numbers for me to graph. That is a negative 3 pi over 8, negative pi over 4, negative pi over 8, and 0 finally. Okay, so those are going to be my x values. Now these can be a little bit tricky, guys, but it's just fraction math with some pi's thrown in there to confuse you. Okay, so now that we've gotten the x coordinates, let's go ahead and start the y coordinates. Well, again, I'm going to take a second. Let's label these as being our x coordinates, and let's move on to the y coordinates now. So my y values, same pattern. I've been using it before, right? Undefined, -1, 0, 1, and undefined. And what's happening to my y values? Well, according to my equation, they're just being multiplied by -3 here, which causes actually both transformations, the vertical reflection and the vertical stretch. So I'm going to do the same thing to my y values. I'm going to multiply them by -3, okay? And we should get undefined, 3, 0, -3, and undefined again, all right? And now I can lock these in as my y values, okay? So these two columns right here, my x and my y values, will make up my coordinates for this graph, okay? Again, my suggestion, let's just start with the two asymptotes right here and right here. And according to this, I'm going to put these on the graph first. We've got an asymptote at negative pi over 2, so right here. And we've got another asymptote at 0. Wow, this graph is pretty crunched down, okay? So we're just going to have to do our best to try and fit everything in. And I'll start with the middle point. Negative pi over 4 is 0. So here's negative pi over 4 right in the middle of those two. And I've got another point, negative pi over 8 at -3. So just kind of guesstimating where that is right there. This one's going to be at +3, okay? And again, making like this little cubic looking thing, a little bit of a tight fit there, okay? And if I wanted more copies of this graph, guys, all I do is project outward my asymptotes, right? And say, hey, this was negative pi over 2 to this. Go forward one period, and then just kind of draw the same shape again. Put that midpoint in there, get that point that's at -3, get the one that's at 3, and just kind of go, hey, there's my graph again, okay? And you can repeat that as many times as you want to make more copies of it, all right? Let's go ahead and take a second and let's calculate out the period, okay? So the period is again pi over b, and this time my b value was 2. So if I plug this in, we should get pi over 2 as my period, all right? And if we were to refer back to the formula we wrote for asymptotes earlier, right, you'll remember that the asymptotes are the first one plus the period times n, okay? So my first asymptote, I personally like taking the positive one, or the one that actually is at the bottom of my chart. I'm just going to use this one right here, okay? So I'm going to have my first asymptote at 0. I'm using the x values, okay? And I'm going to go ahead and say plus my period, which is pi over 2 times n, okay? And 0 ends up being completely irrelevant to me here. And finally, I would say the equation for my asymptotes is just going to be pi over 2n, all right? So that's an example where we found the period and we found the formula for the asymptotes, just as some extra information that you may want to have. And that is graphing tangents, guys, in a nutshell, all right? Same thing as sines and cosines, some different points, some slightly different shaped graphs, and a slightly different calculation for the period, okay? But keep in mind how you calculate your period and that asymptotes formula, all right? Those may come in handy in the future, hint, hint. I hope you guys enjoyed the video and learned a lot from this. All right, happy studying.